Hi, I am IT PhD and today we continue our interest in C language and we would come back to developing our game next time, but for now we should learn about binary system, hexadecimal system, how they work. So today I'll explain it. In our past lesson we looked into variable types and we saw interesting things. So when we define character type, which by default characters they all signed, signed. So it means that signed character it's from minus 228 till minus till 100 from minus 128 till 127. So if we would put something bigger here, we would have overflow, you see. So we would have wrong output, which is very bad thing and cause trouble. But why we have this problem? So basically in your computer everything, all information stored as a 0 or as a 1. So imagine we humans could operate with decimal system. So we use 10 different signatures for each number. So to count something like 1 banana, it will be 1. If we see 2 bananas, it will be like we have sign 2. If we see 11 bananas, then we take 1 and then add another 1. It's like we take this like decay. We take 10 and add from the scratch all of these characters which we need. In the PC there is no such big amount of characters, only 0 and 1. It's come from, like, you know, when your bulb lit or it's dark. So it's like existing something or nothing exists. So if you have only 2 characters, the way for you to write numbers quite limited. For example, to write like 1 or 0, it's alright. But if you want to write 2, and you could use only these 2 characters, how to do so? So people found out that it's quite possible. So to write 0, it's 0, to write 1, it's 1, and to write 2, what we could do, we could just add another character here and removed first character. So it's kinda 2 in binary system. But if we want to write a number 3, then we kinda use another one and we write, now it's 3. So let's to explain it, we should write all this stuff, but we would write it from right to left. So we have here 0, 1, 2, 3, 4, 5. Let's go till 7, till 8. So in binary, it's decimal. So in binary, let's write it binary. 0, it's a 0, it's quite understandable. 1, it's a 1. To write 2, we need to figure out how to use only one of these characters. So to write 2, we use like 1, 0. Okay, to write 3, we could use like such a way to write it down. It's just a way how we could write it down. So to write 4, what we could do, we could like add another 1 to the left and to do it like this. So you understand the principle. Now to write 5, for example, we take 4 from here and we add 1 at the end. So now we wrote, let's make a bit more space. So to write 6, if we could use only 1 and zeros, we just use all our opportunities which we have. The only way to write it, we could add like these 2 ones here, and here we have a 0. Why it's so? Because we know that 2, we know that 2 written like this, so we write it here. And we know that 4 written like this, so we write it here. And if we would add like 4 and we add 2 to it, then we have 6. Yeah, so it's we take 4, we take 2, like plus, so it will be 6. And this way it's going on. So to write 7, for example, we just put everything like this. So we add 1 to 6. So 6 plus 1 will be 7, like this. So it's how binary could be written. Interesting thing about it, it's that actually all these numbers, if you would look into it, they have certain interesting, yeah, let's write 8 also. It's kind of important number. So 8 will be written like this. Yeah, 8 will be written like this. And you may notice that, okay, here we have 0, here we have 10, here we have 100, here we have 1000. So it's 0, like 2, 4, 8. So basically each binary next, we add next number to binary when we have like base of 2. 0, it's a 0. 2 to the 0 power will be 1. 2 to the first power will be 2. 2 to the second power will be 4. Then 2 to the third power will be 8. And here we see it like 10. It's not a 10, it's like 1 0, 1 0 0, 1 0 0. So we see that we add like a new number to the left. It's called most significant bit, because we add it when we increase our power of 2. And this bit is called less significant, yeah, because we could kind of use it to add just the least smallest piece of information. So this way, if we would go on, let's write some stuff. So 0, 1, 2, then we know that, okay, 2 into the second grade is 4, 2 to the third grade it's 8, then we could continue to the fourth, to the fifth, and so on. So you could see that we kind of write this sequence, and now we could easily write binary numbers here. So binary, in binary it will be, let me use other color. In binary it will be like this. It's 4, it's 8, yeah. So now it's 16, and so on. So it's how you could know, how you could easily calculate binary numbers. So for example, you have number something like this, some just random number I wrote here. How to understand what's what here? So we see that the most least significant bit, it's 1. It's always like 1. Then we know that this bit, it means 2. We know that it's, you could even write it down like 1, 2, this is 4, this is 8, this is 16. So we have here 1 from the least significant bit, then we have here 4. Yeah, so we know that it's like already 1 plus 4. Then we do not have here 8. It's just empty, you see it's 0, and we have here 16. So now if we just add it, it will be like 5, it would be 21. So even if you would try to go to calculator and you will calculate this number, you could go to choose binary mode in the calculator and you will enter it. Yeah, you see it's in decimal, it says that it's 21, so we calculated it properly. Let's make some more examples. So just to make everything more fluid, to be more fluent in it. So let's take a bigger number, like some huge number, some random number, and we will try to get through it together. Okay, you see it's really big one. And again, first of all, we would take that, we know that this is 1, this is 2, this is 4, this is 8, this is 16, this is 32, this is 64, this is 100, 200, 128. Yeah, it's, if you need to have a bigger, okay, it's 256, just small place here. This is 512. This is 1024. I know it by heart. And yeah, in time you would also kind of remember such stuff. 248. So here with the same, we could see that, okay, we have this number. So this number we have, it's 1. This we do not have, it's 0. This we have, though, we have already 4 here. This we do not have. This we do not have. This one we have, so it's 32. This we do not have. 128, 256, 512, and this we do not have, and 2048. So now if we would just make some basic calculation, yeah, I do not want to bother with we would just use our calculator. We would go to like decimal mode and we will write like 1 plus 4 plus 32 plus 128 plus 256 plus 512 plus 2048. So we have this number 2981. So now if we try to go to binary, we see that this is our number. So 1011 1010 0101. So you see we calculated properly. It's how you could calculate it. Very handy thing to remember this, because yeah, actually you will need it. You need an understanding of binary numbers and how they are written. Why it's important? It's important because yeah, let's go back to our thingy here. Let's go back to our basic thing which we did. So we took number one. We have character here. Let's make it like this. Yeah, I'll draw some more stuff on the screen. So why, when we do this, when we compile this program, why it returned to us minus 128? So we want to put to this character, we want to put this number 128. Let's write it. So first, the easiest way to do it, it's like to write a small reminder for you. Like always do this, like 4, 8, 16. Why am I doing it? I hope that you could also like 32, 64, 128. So what does it mean? We have here 128. It means that we kind of getting this number 1 0 0 0 0 0 0 0 0. This is our binary number, and it has in it, here we have 4 zeros, here we have another 4 zeros, and here we have this one. So the thing is that character type, this character type, it could hold itself only byte. What does mean byte? Byte, it's 8 bits. So here we have 4 bits, and here we have 4 bits. So it's 8 bits. So maximum number for character could be held like in this 8 bits. So maximum number will be here and here. It's maximum number, and this maximum number, it's if you see here, so this bit, let's take this color, so this bit, it's 64 bit, yeah, because it's like the same. So we have here 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 plus 1, yeah. So this number, basically, it's, I just know this number. So this number, it's 255. So we wouldn't calculate it. It's for 255. So to have number bigger, to have bigger number, we need to add another 1 to the beginning. So if we would add here 1, and all other stuff will become 0, it will be 200 like this. So if it will become like this, we would add 1. So it will be already 256. Yeah, as you might remember it from here. Okay, I wrote it just recently. I showed it. So thing is that our character, you know that it's by default it's signed. And signed, what does it mean? It means that basically a character could be from minus 128 to plus 127, because it's signed. It's still, so it still must be held in 8 bits. In 8 bits. So 8 bits, it's 1 byte. So byte, it's like 8 placeholders, 8 boxes. And here in each of these boxes you could put 1 or 0. Yeah. So you have these 8 boxes. The thing is that if you have unsigned character, it means that you could use all these boxes, and this number, it could be up to 255. Yeah, because we have 8 boxes, so it will be up to 255. But here we have that we are trying to put inside 128, and our program generates us wrong number. Why it's so? Because actually, as it's signed number, we use not all 8 boxes, but actually we use only like 7 of them. Why? Because one more significant byte or more significant bit, it's used for sign. So this one box here, it's used for sign. It could be plus or minus, and another boxes, they used for actually number. Yeah. Okay, something like this. So we have here 4 boxes, and here 4 boxes, and this box for signed values like this character, it's used for sign. So if there will be 1, then it will be minus value. So it will be a negative value, like minus 128. But if there will be 0, then it will be like a positive number. It's how computer has to store its data. So there is no other way like to say that, okay, it will be a negative number in this particular small box in the memory. Yeah. So that's why. So what we have here, let's go. We have a box. Let's remove this stuff so we will have more space. We have a box. We have here signed character. So nice box. So here we have 8 and here 4, and here we have 4. So it's a byte. And this byte consists of 8 bits. So this small thing, it's bit. Binary digit. So shorthand for bit, it's a binary digit. It's nice to remember this thing. Binary digit. So the thing is that here we're trying to put, so here we have our bit for sign, because it's signed value, and it could be 0 or 1. So if we have number 127, let's imagine that we have here 127. How we will write it down? We would write it down like this. So this is 127, and here we have 0 because it's like plus 127. If we would like to write down to store minus 127, here we will have like this bit will be 1. Yeah, but here we have plus 127. So now we want to put here 128. What does it mean? It means that we take this number, and we computer, it's stupid. It do not know what do we want from it. So he just make what you ask him, and you ask him to put the number. You ask him to put this number to this box. He do not ask you questions. He just do what you told him. So he takes this box and he put this number, because like 128, what does it mean? It's he put here 1, and other stuff 128, it will be zeros. But this character, it's signed character. So this bit, it's reserved for sign. So what your computer think when he show this value? He know that this variable, it's signed character, and for signed character he look, okay, it's signed character, so I look in this bit, this most significant bit, it's like sign. So here we hold our sign, and it's 1. It means that it's negative value. He think, okay, it's negative value, and as all other stuff, it's zeros, so it will be, yeah, it will be minus 128. Why minus 128? It's if it's all zeros, because yeah, it's people thought that to make it more effective, to be able to hold one more number, they would say that if there are all, for signed values, if there are all zeros inside, it will be like minus 128. But if we would, for example, we do like this, if we would put here 129, so now you see it shows 120 minus 127. Why it's so? Because we kind of also put here a 1 to this. So now we're putting here 1. So it's how negative values stored in your computer. So signed bit, and this thing, it show you like everything is kind of vice versa. Yeah. Now let's talk about some another important stuff. Let's take a look at basic operation. For example, we would take a number, like just random number, and let's learn how to use addition, subtraction within binary. It's actually very easy, and it could feel hard, but actually it's not. So basically, if you want to make addition, how it works. So you see here we have like a 0, and here we have 1, and if you make 0 plus 1, it will be 1. So here we also have 1 plus 0, it's 1, 0 plus 0 is 0, and 1 plus 0. If you remember your school, it's kind of what we can't write here 2, because we have only binary numbers. That's why we write here 0, and we move 1 to the next bit, to most significant bit. So, and we then draw it. So we just, what we did, let's learn a bit. So this is 2, this is 4, this is 8. So we made like 10 plus, this is 1, and this is 8. 10 plus 9. 10 plus 9, it's 19. So here what we have? We have 1. Let's take another. We have 1. We have 2. It's 4, 8, 16. And here we have 16. So 16 plus 2 plus 1, it will be also 19. Now let's try to make addition for such numbers. So we have this number and this number. So let's see what will happen. It will be 0, it will be 0, 1 will go here, 0, 1 will go here, it will be 1, 1 will go here, 1, and it will be like this. So let's test it. We would see that what number we had in the beginning. So it was again like 1, 2, 4, 8, 16, 32, 64, 128. You actually could remember it easily just by looking for that there is a 4 numbers and here 4 numbers. So 8 numbers, it's always 128, because maximum amount for 1 byte is 255. So sum of all these things, it's basically 255. So what we have here? We have 2, we have 8, we have 16, we have 64, and 128. So if we would add it, okay, just to short our time, I calculate everything already. So the thing is what I'm trying to show here. So we took 218 and added to it 154. And we have result 372. And what we made? We took 2 numbers, each of these numbers, they were kind of in 1 byte. But the result, outcome, we have more than 1 byte. The result, we have extra number. which go to the most significant bit, and it brings us this problem. So if we would try, if we not only like adding some stuff, but if we take like foo, let we have here like normal number, but then we add to foo like 100, we also could make overflow. So you need look for this stuff, and now you understand why it's happening. Another thing which every person should know, it's hexadecimal numbers. So yeah, there is also subtraction, like multiplication, other application. You could just Google it. It's like just the same as in real life when you make these calculations. Not hard, and you basically do not need to do them often. Oh, there are binary operations also. We would talk about them, but for now, yeah, let's go for hexadecimal. So hexadecimal, basically, why people use them? Yeah, we have kind of very nice way to write numbers in binary way. So in binary, we could know that, okay, it's 128. Yeah, because we know that it's 1, it's 2, it's 4, it's 8, it's 16, 32, 64. You actually should remember this thing, because yeah, you will use it very often. Yeah, but actually writing down such stuff, it's not really easy. I mean, like this. So there is a way to write it down very easily, much more easily. It's hexadecimal mode. What does it mean? In real life, we count from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like this. So what people thought, okay, we could also count other way. We could count not till 9, but till 15. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Then add A, B, make it bigger, C, D, E, F. So basically, after 9 we have 10, 11, 12, 13, 14, 15. And here it's kind of the same. So you have B, C, D, E, F. And why it's used very often? For example, let's take our program which we just compiled, this our hello world, and let's open it in binary mode. How to do so? Yeah, you just put it to the notepad. Here is a plugin, Hexi Editor, so you could say that, okay, please view in hex mode. And in hexadecimal mode, what we see here, it's just the content of this executable file in binary. And we do not see here stuff like zeros and ones. Why? Because actually we have here zeros and ones, but we see it like such numbers. So let's copy this 4D. Let's take 4D. What does it mean? So basically we know that D, it's 13. We already know it. So it will be like this. But what it's for? The thing is that when we count till 15 in hexadecimal mode, how to write 16? The question is. So to write a 16, we add next significant, not a bit, but hex. So we write here 0, 1. So 1, 0, it means 16. And basically, you do not need to remember this notation, like hexadecimal. but because you always could check it like this. So if you would open calculator and you will like enter hex mode and you enter here 10, you will see that in decimal it's 10. So for example 4D, it means if we would here put it 4D, you will see that it's in decimal it's 77, but in binary it's this number. And here we comes to the purpose of why all people who code, they use these hexadecimal numbers. Why our binary code using hexadecimal numbers? Because actually, you see this number here in our calculator, we could put this huge number. So let's write it down, this number. So 0 1 0 0 1 1 0 1. This number this is 4D or 77. So it's 77. We know it already. The thing is that in binary, to write this number, you need to kind of write a lot of things. And as you know, programs, they are stored like this. So for us, for humans, it's much easier to show not this thing, not show this huge thing, but just to write 4D. Yeah? Because, yeah, it's totally alright for PC. So let's compile it again. It's totally alright to open this program, to open Hexi Editor and show in this Hexi Editor, show not 4D, but show you all these zeros and ones. But for us, it's much easier to read it like this. So instead of looking at big number of zeros and ones, which is much less human readable, we could see that, okay, 4D, 5A, and if you want to understand which bits inside, so which zeros and ones, you could just put it in here, like, and here you see, okay, this 4D, it means this number in binary. So actually you could even in some binary Hexi editors there is a binary mode and you could check how it looks with the zeros and ones without this. So it's just for humans. So basically it's very convenient to read binary code in hexadecimal because it just take less space. That's it. That's why everybody using hexadecimal. Yeah. Also, there is an octal mode also. Like octal mode, it's kind of the same thing. So let me show it. Okay. So in octal mode, you have not 10, but just 8, 7. So you can't, yeah, it's called octal, but basically you do not have 8 number. There is no 8 number here. You just use this stuff. And you could also, like, if you want to write 8, what you do, you write it like this. Yeah, you just add another significant sign here. So again, you could open calculator, and in your calculator you could like put here in decimal. Let's take a look at 8. So 8 in decimal, in 8 in octal, 8 in octal, it's 1 0. For example, if we would take 7D, so in octal it would be 175. So you could use this calculator to look into this stuff. And of course you could use output or in different systems. For example, this is decimal, but if you would put here X, it will output for you hexadecimal. So 69 in hexadecimal, it looks like 45. So if we would put 16 here, for example, 16, Oh, let's put 15. It will be much better. You will see F, because in hexadecimal 15 it's F. So if you want octal mode, you could put O. And in octal 15 it's 17. In octal, for example, 8. In octal it's like 1 0. It's important thing because sometimes you use not octals. Octals they are very rarely used, but hexadecimal it's very useful thing. Octal used only in some old programs, but hexadecimal is used very often. And when you see stuff like 0x something, it means that it's octal. It's hexadecimal. So if you make it like this 0x f, this number, and you would want to show it in hexadecimal, you will see that okay, in decimal you will see that okay, it's 15. So to assign hexadecimal you do it like this. To assign octal you just add 0 before. So let's try. Yeah, you see? So it means 8. That's it. I think, yeah, that's it for now, because we already made a quite long video. I hope I uncovered some internal things in PC for you, and I'll make more videos for you. So our adventure in C language will continue, and we will continue to develop our game. Hope to see your comments. Thank you very much for watching. Have a good day. Bye bye.